In this video, I want to have a look at functions with asymptotes. So the first family of functions I want to have a look at are exponentials. So exponentials have an equation that looks something like y equals a to the power of x, where that a is a number. So for example, it could be like y equals 2 to the power of x, it could be y equals 57 to the power of x, it could be anything. So the graph of an exponential with one of these basic equations looks something like this. So we can see that as our x values get larger in the positive direction, that graph is getting bigger and bigger, so our y values are increasing. And because that graph is getting steeper as well, it means they're increasing at an increasing rate. As our x values get large in the negative direction, so we're moving towards these big negative numbers, we can see that our y values are getting smaller and smaller, and they're getting really close to 0. It's really important with exponentials that we know that that's never actually going to reach 0. The y value will never actually equal 0. It'll just get infinitesimally close. So it's going to get incredibly close to this x-axis, but it will never touch it or cross it. So what we call that is an asymptote. So because our x-axis is an asymptote, the asymptote is the line y equals 0. The next functions I want to look at are called hyperbolas, and they're going to have an equation that looks something like y equals 1 over x. So this is what it looks like. It's got these two different sections in different quadrants. Now, if we look at that equation, we know that x cannot equal 0 because we can't divide by 0. So that means that this equation, this function, is undefined at x equals 0. So that means it's never going to have a value, or it's never going to cross this axis down here, this y-axis. So that's one asymptote then. So that's at x equals 0. So this graph is going to get incredibly close to that y-axis, but it's never going to touch it, and it's going to do the same as it comes down this way as well. Now, if we were to rearrange that equation, so we've got y equals 1 over x, if we wanted to make x the subject of that, we'd have to multiply both sides by x, so we'd have x times y equals 1, and then we'd divide both sides by y, and we'd have 1 over y. So now we can, using the same sort of logic we did at the start, we can see that we can't ever have y being equal to 0 either. So our asymptote, there's actually going to be a second one this time, and that's going to be at y equals 0. So when you've got a hyperbola, it's never going, or one of the basic hyperbolas, it's never going to touch that x-axis either. So it's going to have two asymptotes, one on the y-axis and one on the x-axis. Now it's really important when we're talking about where the asymptotes are for different types of functions to recognize that if we shifted the whole function, transformed it up or down or left or right, then the asymptotes would move as well. And that's something we're going to have a look at in one of our later videos. So that's a few examples of functions with asymptotes.